few days ago, we introduced binomial random variables by looking at a scenario where I'm shooting 5 free throws. I'm a 40% free throw shooter. So we were using a model where X is the number of free throws that I make out of 5. It is distributed binomially with 5 trials and a success probability of 0.4. Now, in order to find the mean and the standard deviation for this random variable, I had you put the outcomes into list 1. I had you put the probabilities into list 2. And then I had you use the one variable statistics command. So on the one variable statistics command, if we use list 1 as the list of outcomes and the frequency or the probability list as list 2, this command will give you the mean and the standard deviation of the random variable. So the mean is 2. That's also the expected value. The standard deviation then is about 1.1. So that's where we ended up previously. Here's the mean of 2, the standard deviation of 1.1. So the interpretation of the mean is that the expected number of free throws that Mr. Schaaf makes is 2. The interpretation of the standard deviation, this tells you typically how far above or below the expected value you may be. So typically Mr. Schaaf makes between 0.9 and 3.1 free throws in 5 attempts. So what I wanted you to see, though, is that there's a formula that you can use rather than taking the time to put the outcomes and the probabilities into the lists. There are formulas that you can use to find the mean and the standard deviation. So the mean for a binomial random variable is just the number of trials times the success probability. So in this context, there are 5 trials. My success probability is 0.4, and 5 times 0.4 is 2. The standard deviation then can be found by taking the square root of n times p times 1 minus p. So that's the square root of the number of trials times the success probability times the failure probability. So 5 trials, a success probability of 0.4, 1 minus 0.4 is 0.6. That's the failure probability. So if you put that in your calculator, you'll confirm our previous answer. So the square root of 5 times 0.4 times 0.6, that gives us, again, the same thing we saw using one variable statistics. There's the standard deviation of approximately 1.1. So I want to take a few minutes and give you an idea of where these formulas come from. You don't have to memorize these formulas. We will give them to you if you're taking a quiz or a test, and they are on the AP exam formula sheet. So here's where the formulas actually come from. So let's consider a different binomial random variable. I'm going to call it z. And z is the number of free throws that Mr. Schaaf makes, but out of only one attempt. So z is a binomial random variable. There is only one trial. This is my fixed success probability. And again, as we've discussed before, there are 2 outcomes. I make it or I miss it. And we've talked about the independence condition before. So what makes this extraordinarily simple is there is only one trial. So there are only 2 things that can happen here. I either miss it or I make it. So we have previously looked at formulas where we can calculate the mean and the standard deviation of a discrete random variable. Well, this is discrete because I can list the number of successes. Since I'm only throwing 1 free throw, I either have 0 successes or I have 1 success. So to find the mean, I want to take every outcome times its probability. Well, look, there's only 2 outcomes. The first outcome is that I don't make the free throw. I have 0 successes. And that the probability of that outcome is just the failure probability, which is 0.6. So this means sum, so I need to add to that the other outcome times its probability. Well, in this case, the only other outcome is that I have 1 success. I make the free throw, and that's multiplied by its probability. That's the probability of a success. So the mean for the random variable z, again, z only has 1 trial. The mean for this, the 0 times the 0.6 is just 0, so the mean is simply 0.4. Now it's important I do that first because now we're going to use the formula for the standard deviation. So the standard deviation involves a radical, and I need to take the sum of every outcome minus the mean. I need to square that and multiply by that outcome's probability. Well, again, there's only two outcomes. So when I take the sum, there are only two terms. The outcomes are 0 and 1. 0 means I don't make the free throw. 1 means I do make the free throw. So under the radical, here's the first outcome. That's 0. So I subtract the mean. That's what this says. I need to square it, and then I need to multiply by the probability of this outcome. The outcome of 0 means I have failed at my free throw, so that probability is 0.6. This is a sum, so I need to add that to the other outcome, which is 1 success. I've made my free throw. I need to subtract the mean. So the mean is the 0.4. We've already calculated that. That's why I'm recycling it here in this formula. So the outcome minus the mean, I need to square that and multiply by the probability of this outcome. Well, this outcome means I've made a successful free throw. That's 0.4. So if you take the time to put this expression into the calculator, everything under the radical here simplifies to 0.24. So again, if you take 0 minus 0.4, that quantity, and square it and multiply by 0.6, plus 1 minus 0.4, that quantity squared times 0.4, this simplifies to 0.24. So my point is the standard deviation for z, now understand z is only one trial. The standard deviation for this one trial is the square root of 0.24. And I'm going to leave it like this because now we're going to turn z, we're going to use a combination of z in order to make the original random variable. So remember, the original random variable that we were working with was x, and x has 5 trials, 5 free throws. Well, what that means is to create x, I need to use 5 z's. Z represents the binomial random variable where I am throwing only 1 free throw. I need to combine 5 of those in order to make x. So this is what it looks like. The random variable x then is 1, 2, 3, 4, 5 random variables, 5 z's put together. Every z represents 1 free throw. Now be careful, this is important. You can't just add these and say that z plus z plus z plus z plus z. You can't say that this is equal to 5 times z. Understand, if we did that, we don't want to write it this way. This is important. So if you do this, what you're saying is, if you miss the free throw, if z is 0, that means you miss all 5 of them. If z is 1, if you make the free throw, what that means is you make all 5 of them. That's not what we want to do with random variables. We want each of these z's to be independent of one another. In other words, this is my first free throw. Maybe I make it or I miss it. Here's my second one. Maybe I make it or I miss it. But I want each one of these has to have the opportunity to be either a 0 or a 1. So understand then, to find the mean of x, I have 1, 2, 3, 4, 5 z's that are added together. All I need to do is add up the means for each one of those z's. So every one of the z's has a mean of 0.4. That's what we found up here. So that means the mean of x is 0.4 plus 0.4 plus 0.4 plus 0.4 plus 0.4. That's simply 5 0.4s. Well, understand, the 5 is n. The 0.4 is p. There's the formula for the mean. Rather than doing all of this work, we can just take n times p. So let's look at the standard deviation then. To find the standard deviation for x, if all of these 5 z's, if they are independent of one another, and there's the importance of the independence condition, if these are all independent of one another, then I can take the standard deviation for each of these z's, I can square them. So understand, here's the standard deviation. I am taking that standard deviation 5 times. I am squaring that standard deviation. Then I can add them together. There are 5 z's, so I have those 5 squared standard deviations. Those turn into what are called variances. So understand, under the radical then, what I really have under this radical is 0.24 plus 0.24 plus another 0.24 plus another 0.24 and one final one. So what I really have are 5 0.24s together as I'm simplifying this. So I can rewrite this as 5 times 0.24, but here's what's special about the 0.24. 0.24 is the same as 0.4 times 0.6. 0.4 times 0.6 makes 0.24. So understand, this is where the n times p times the 1 minus p comes from. There's 5. That's the number of trials. 0.4 is the probability of a success. 0.6 is 1 minus 0.4. That's 1 minus p. That's the probability of failure. And they're all together underneath that radical. So there's where the formula comes from for the standard deviation of a binomial random variable.